Welcome back, everyone. We're going to finish up chapter 9 by doing sections 9.3 and 9.4. We're going to start with two dependent samples now, and we're going to look for the differences between them. So, for example, if there's a weight loss program, and we have the before weight and the after weight. So before they weighed 190 pounds, and afterwards they weighed 170 pounds. What we are interested in is the difference, meaning 90 minus 70 is 20. So that's what we're going to focus on. Maybe before it was 175, down to 150. That's a difference of 25. So we will be interested in this list here. Now, these are dependent samples, meaning it's the same person, right? The one person weighed 190 before, and afterwards they weighed only 170. So is that big enough difference? Can we claim that that difference is significant enough? Is what we're going to be testing. And we have some vocabulary that we need to deal with. First of all, this is going to be a t distribution. So our degrees of freedom are going to be n minus 1 once again. Once we get to chapter 11, the degrees of freedom are going to change a little bit. We're doing a few more creative things. And I want to define some of these letters that we're going to be using. For the individual differences, that's going to be D. So these are both Ds, individual differences. The mean value of the differences for the population is our mu sub D. Now, our null hypothesis is going to be that mu sub D is 0. We're going to assume that there is no difference, meaning the weight loss program, we're assuming it's not going to work. If you say that it does work, then you need to provide evidence that it does. The mean value of the differences of the sample is going to be D bar. And then the standard deviation for the sample is going to be S sub D. And you can see in our test statistic here that we're using all of these as part of this. Now, when we're doing a confidence interval, you can see the formatting is going to be all about mu sub D once again. And once again, our degrees of freedom are going to be n minus 1. So let's jump into it. And once again, before I even read the scenario, this is the list that we are interested in right here. All right, so let's read the scenario. The owner of a chain of mini markets wants to compare the sales performance of two of her stores, store 1 and store 2. Though the two stores have been comparable in the past, the owner has made several improvements to store 2 and wishes to see if the improvements have made store 2 more popular than store 1. Meaning sales from store 2 are going to be bigger than, so I expect there to be a negative difference as I'm looking at that. So let's set up, again, we're going to assume that there's not going to be a difference, but this is going to imply that mu sub D should be negative if the sales are higher in store 2. So we expect that difference to be negative. And you can see in the pink there that we got a lot of negatives going on. Sales can vary considerably during the on the day of the week and the season of the year. So she decides to eliminate such effects by making sure to record each store sales on the same 8 days chosen at random. She records them in dollars for each store on these days, as shown in the table below. And as I mentioned before, by the way, we can see right here that our degrees of freedom is going to be the 8 minus 1, or 7. All right. So based on this data, can the owner conclude at the 10% level that the mean daily sales of store 2 exceeds that of store 1? Answer this question by performing a hypothesis. We already did all this. The difference between 2 stores. Yes, okay, so let's get started. Please take a moment. I put this list into list 1 already in my calculator. You can see the negative 161, the negative 168, and so on. So you may need to pause this to put that data into your calculator. This is going to definitely be a t-test. And because it's less than, it's going to be a left tail test. And we are at 10%, which means I'm going to be using inverse t, 0.1, comma, and our degrees of freedom is 7, because there's 8 here. So let's go ahead and do that. So I'm getting negative 1.4149. And this is just going to be a straight up t-test. And it's in my list 1, so hopefully you've done that already. So, oops, we want to do stat test. This is straight up t-test. And this is going to be 0, x bar. Oh, no, we're using a list, sorry. List 1. And this is going to be a less than scenario. And let's see what we got. All right, so we have our test statistic, which is t. It's about negative 3.7289, we'll say. And our critical value we've already gotten. And we can see our p-value in the calculator there is less than even 1%. So our critical value is negative 1.4149. And I can see that this is definitely way over here. In fact, that's probably not even, it should be even more left. But we are definitely in the rejection region. So our conclusion is to reject the null hypothesis. So at the 10% level, can the owner conclude that the mean daily sales of store 2 exceeds that? Yes, we can. Because our null hypothesis says that there is no difference, and our alternative says that it's less than. Sweet. All right, let's do a confidence interval. Now I have put this information into list 2 for my calculator. You may need to take some time to put that into yours. Here we go. A personal computer manufacturer is interested in comparing assembly lines for 2 keyboard assembly processes. To do this, the company selects 11 workers at random and asks each of them to use both assembly processes. The assembly time in minutes for process 1 is recorded. Then the assembly time for process 2 is recorded. The data is shown below. And once again, I want to make it clear, we are interested in the differences. And we're going to assume that these differences are approximately normally distributed. Construct a 90% confidence interval for this. So this is going to be a straight up t interval. And again, I have my data in list 2 already. There it is, t interval. We are going to use raw data from list 1. And our alpha is 0.9. And here we go. There is our something is not right. Let me make sure. Got my list 2. Sorry about this. Oh, I did it on list 1. It should be list 2. So let's run it again. So stat test t interval. I have to change that to list 2. Second 2. There we go. Now it matches my notes. 8.118 up to 23 0.154. That is my 90% confidence interval. So we're 90% confident about that. Now you'll notice again, well, anyway, that is our conclusion there. So let us highlight that and then move on. The last section is the same, except we're going to be doing with a proportion instead of a mean. All right, the samples have to be independent, simple random samples. The NP hat and Q hat have to be bigger than 5. And our test statistic is going to be, our null hypothesis, I should say, is going to be P sub 1 equals P sub 2. So we're going to assume that the two proportions are the same. Remember, a proportion is like a percent. And you can see all of this information here. We are going to be given X and N. And we're going to be running a two proportion z-test, or interval, if we have a confidence interval, of course. All right, and you can see all these formulas here. They're all great. We don't need this degrees of freedom because proportions are always z-tests. So let's jump into it. Based on advancements in drug therapy, a pharmaceutical company is developing Resithan, a new treatment for depression. A medical researcher for the company is studying the effectiveness of Resithan as compared to their existing drug, Examor. A random sample of 419 depressed individuals is selected and treated with Resithan, and 180 find relief. So that's going to be, so let's make a list here. So our Resithan versus our Examor. All right, so our X sub 1 for Resithan is the 180, and N sub 1 is the 419. And Examor, X sub 2 is 223, N sub 2 is 549. Based on the medical researcher study, can we conclude at the 5% level that the proportion 1 of all depressed individuals taking Resithan who find relief from depression is greater than that? All right, so let's start here. P sub 1 equals P sub 2. And now we're saying P sub 1 is bigger than P sub 2, making that a right-tailed test. All right, so let's draw our picture. And this is a large, so this is a right-tail test. And that is at the 5% level. So I'll need to use inverse norm of 1 minus 0.05. So this is 1.64485. All right, let us run once again, we're going to be running this is Z. This is going to be a 2 proportion Z test. All right, so X sub 1 is 180. N sub 1 is 419. X sub 2 is 223. N sub 2 is 549. This is a larger than or equal to. And here we go. So let's get our test statistic. Z is about 0.7318. And this one, you can see our p-value is quite large there, the 0.232, which is definitely bigger than our alpha. But this one, they're using critical value. So this is, Z is about 1.64485. And we can see that this is definitely way over here. We are not in the rejection zone, rejection region. So we're going to fail to reject the null hypothesis. So can we conclude that the proportion of depressed individuals taking Recipan who find relief is greater? Nope. We cannot. We're sticking with the null hypothesis where we think the proportions are still the same. And finally, we have a confidence interval. This is going to be a two proportion Z interval. To determine the possible effect of a chemical treatment on the rate of seed germination, 350 chemically treated seeds and 250 untreated seeds were sown. It was found that 308 of the chemically treated seeds, so let's, X sub 1 is 308, N sub 1 is 350, X sub 2 is the 205, N sub 2 is the 250. And 205 of the untreated seeds germinated. Let P sub 1 be the proportion. So we are looking for a confidence interval where we have the difference in the two proportions like this. And we want a 90% confidence level. So stat tests, we're looking for 2 prop Z interval. There it is. B for me. Not sure what happened there. Okay, so let's do this. X sub 1 is 308, 350, 205, 50. Our confidence level is at 90%, so we're good there. And calculate. And there we are. Let me double check my numbers. Test 2 prop Z interval. Sorry about the advertisements. And so 308. $350, yeah. 205, yep, of the 250. And 90%. All right. So it's looking like we're getting, let's move that over there. Here is our confidence interval. There it is. So the difference is going to be between 1.1% and 10.9%. I hope you found this helpful.